Hi guys, in this video we'll look at the equation of a circle, determining the equation of a circle, examples, and then we'll finish with a summary.
So what is the equation of a circle? Consider a circle drawn on an xy plane. Here we have a circle on a given xy plane. The important properties of a circle are the centre and the radius. So in the middle of the circle we have the centre of the circle. And if we draw a line from the centre of the circle to the edge of the circle, the length of this line is known as the radius. This will be constant no matter which point you choose on the edge of the circle to draw the line between. We know that the equation of a straight line is completely determined by the line's y-intercept c and the gradient m. So firstly, where the line meets the y-axis, we have the y-intercept of the line. This value we refer to as c. And similarly, looking at the rise and the run of the given line provides us with the gradient m of the line. And this motivates our general equation of a line, y is equal to mx plus c. Similarly for circles, we can come up with an equation containing both the centre of the circle and the radius of the circle. So given the centre of the circle, which is at coordinates a, b, and the radius of the circle, which we'll write as r, we'd like to be able to use this information to give us an equation for the circle. X minus a all squared plus y minus b all squared is equal to r squared. So how can we show this as the equation of the circle? Consider a circle centered at the point AB with a radius r. So we have this center which is at AB, and therefore the value A is here on the x-axis and the value B is here on the y-axis. And then again, if we draw a line connecting the center of the circle with the edge of the circle, the length of this line is r, the radius. Let the coordinates of a point on the circle's circumference be, in general, xy. So again, we have this center which is at AB, and then we have the length of this line which is r, and this line connects the center and a point on the circumference, which we're going to write in general as x, y. This is going to be our general point on the circle. We can find the horizontal distance between the center and the point xy on the circumference. So again, we have our point AB. This is the center of the circle. We have our radius r of the circle, and then we have our general point on the circle's circumference x, y. Now we know that the distance between the axis and the point is a, or rather if a were to be negative, it would be whatever the positive version is. So if a was minus 3, then the length would be 3 from the axis to the center. And similarly, the length between the axis and the point xy in the horizontal direction is x, for the exact same reason, or at least it's the positive version of x. Either way, the horizontal distance between the center and the point xy, given by this line here, is the positive version of the quantity x minus a. We can also find the vertical distance between the center and the point xy on the circumference. So again, we have our center AB, we have our radius r, and our general point on the circumference x, y. And then looking at the vertical distances this time, we have the distance between the x-axis and the center of the circle is the positive version of b. If b is positive, it's still positive. If b is negative, it just becomes the positive version. And similarly, the distance between the x-axis and the point xy on the circumference is the positive version of y. And therefore, the vertical distance between the point AB, the center, and the point xy, the general point on the circumference, is going to be y minus b, or at least the positive version of this quantity. We can relate the radius and the vertical and horizontal distances using Pythagoras' theorem. In general, if we have our center AB and we have our radius of r and then our general point x, y on the circumference. And we now know our horizontal and vertical distances. The horizontal distance is x minus a, and the vertical distance is y minus b. And therefore, we can use Pythagoras' theorem, and we get that the square of x minus a plus the square of y minus b is equal to the square of the radius, the hypotenuse. And so we have, in particular, x minus a all squared plus y minus b all squared is equal to r squared. This gives us the general equation of a circle. The general equation of the circle is just that. X minus a all squared plus y minus b all squared is equal to r squared. This is for a circle with its centre at the coordinates a, b. These are the values that appear here and here. And similarly, a radius of r. This appears here. We have a simple equation for a circle centred at the origin. When the circle is centred at the origin but has radius r, this corresponds to a centre of 0, 0. And so a is 0 and b is 0, and this reduces to the more simple equation x squared plus y squared is equal to r squared. And again, this is for a circle with its centre specifically at the point 0, 0, and with a radius of r. Again, this just comes from the general equation for a circle with a equals 0 and b equals 0. And so we have x minus the value of a, which is 0, all squared, and then plus y minus the value of b, which is 0, and then all squared. And then this is equal to r squared. And so since x minus 0 is just x, we have x squared, and then we have plus, and since y minus 0 is just y, we have a y squared, and this is equal to r squared. Again, this only holds with the centre at the origin. Let's take a look at some examples. Our first example asks us to write down the equation of the circle with centre at 5, 7 and radius 4. We're asked to determine whether or not the point 4, 3 lies on this circle. Our first step is to make a sketch of the circle. Here we have a circle in the xy plane, and we need it in this quadrant of the plane because of where the centre is. The centre has both the x value and the y value being positive, and so it has to be in the upper right quadrant. The centre is at 5, 7. This was given to us, and the radius is 4. Our second step is to recall the general equation of a circle. In general, the equation of the circle is x minus a all squared plus y minus b all squared is equal to r squared. Our third step is to substitute the values of the equation. We have been given that the centre is at coordinates 5, 7, and that the radius is 4. And therefore, by comparing, we have that a is equal to 5, b is equal to 7, since the general coordinates for the centre is ab, and similarly that the radius r is equal to 4. And therefore, by substituting in to our equation above, we have x minus 5 for the value of a, and then all squared, plus y minus the value of b, which is y minus 7 all squared, is equal to r squared, which is 4 squared. And so our fourth step is to write down the equation of the circle, and all we have to do is to simplify the right hand side, and we have x minus 5 all squared plus y minus 7 all squared, and then the right hand side is 4 squared. 4 times 4 is 16. Our fifth step is to substitute the coordinates 4, 3 into the equation. This is because we are asked to determine whether the point 4, 3 lies on the circle or not. And so we substitute in our coordinates 4, 3, and we'll be looking at the quantity on the left hand side and checking whether it's equal to 16 or not. If the quantity on the left hand side is equal to another number other than 16, it will not lie on the circle. And so by substituting in, we have our x equals 4 and our y equals 3. and therefore we have 4 minus 5 and then all squared, plus 3 minus 7 all squared. This is equal to minus 1 all squared plus minus 4 all squared. And this therefore is equal to 1 plus 16, which is 17. Our last step is to conclude whether or not the point 43 lies on the circle. We have shown that since when we substitute in we get 17, the point 43 does not satisfy the equation, which is the equation of our circle x minus 5 all squared plus y minus 7 all squared equals 16. And this is because when we substitute in our 43, we actually get 17, not 16. And therefore, the point 43 does not lie on the circle. Our second example tells us that given that a circle has equation x minus 3 all squared plus y plus 4 all squared equals 20, we're asked to write down the centre and the radius of the circle. And then we're asked to show that the circle passes through the point 5 minus 8. Our first step is to compare the equation given to the general equation of a circle. We have that our general equation of the circle is x minus a all squared plus y minus b all squared is equal to r squared. Our given equation for the circle is x minus 3 all squared plus y plus 4 all squared is equal to 20. And therefore, we can compare quite directly. What we will do is to write our given equation of the circle in a slightly different form. We have x minus 3 all squared, that stays the same, but we can write our y term as y minus 4, and then all of this squared. And then our radius term can be written as the square root of 20 all squared. This allows us to compare directly. And so our second step is to write down the coordinates of the centre and the radius. By comparing with the general equation, we see that A is equal to 3, and so the centre is formed by the x coordinate of 3, and then the y coordinate of the centre, B, is equal to minus 4. This was important to change our plus 4 into minus 4 in order to compare directly with the general equation. And so the y coordinate of our centre is minus 4, and then the radius, because we turned our 20 into the square root of 20 all squared, our radius r is going to be equal to the square root of 20. Our third step is to substitute the coordinates into the equation. We have the coordinates 5 minus 8, and we're asked to show that it lies on the circle. And so we consider our point, which is x equals 5, and y is equal to minus 8. And then we look at the left-hand side of our given circle equation. We'll write it in the form that they've given it to us, and so we have the x minus 3 all squared, and then the y plus 4 all squared. And then we'll substitute in, and so we have for the value of x 5, and then we have the minus 3 all squared, and then we have for the value of y minus 8, and then we have the plus 4 all squared. Now 5 minus 3 is equal to 2, and so we have 2 squared, and minus 8 plus 4 is equal to minus 4, and so we have minus 4 all squared. And so we have 4 plus 16, which is indeed equal to 20. And so our last step is to conclude that the point 5 minus 8 lies on the circle. Since the point 5 minus 8 does satisfy the equation x minus 3 all squared plus y plus 4 all squared equals 20, since we found we get 20 when we substitute in, this means that the point 5 minus 8 does lie on the circle. Our last example asks us to consider the circle with diameter PQ, where P and Q are the points 5, 6 and minus 2, 2 respectively. We're asked to find the equation of the circle. The first step is to use the points to make a sketch of the circle. And we're given some points which lie on this circle. Our first point that we're given is here, minus 2, 2, and our other point is 5, 6. These are the points P over here and Q over here. And we need to find the centre and the radius of the circle in order to find its equation. Our second step is to recall the general coordinates of the midpoint. In order to find the midpoint of 2 points, we have to take x1 and add it to x2 and then divide it by 2, and then we take y1 and y2 and then divide it by 2. This is the average of the x coordinates and the average of the y coordinates of the 2 points. And so our third step is to find the midpoint of the diameter and write down the coordinates of the centre of the circle. Our 2 points are -2, 2, and 5, 6. And so by substituting into our general midpoint equation, we get the midpoint is going to be at the point -2 plus 5 divided by 2. That's our x coordinate, and then for the y coordinate we have 2 plus 6 divided by 2. By simplifying, we get 3 over 2 and 8 over 2. And therefore this is the point 3 over 2 and 4. And therefore we have that the centre of the circle is this midpoint, which is 3 over 2, 4. The fourth step is to find the length of the diameter PQ. We want this length because we're looking for the radius, and the radius has length half the length of the diameter. And so we can start by finding the diameter. We have our 2 points, which are the points 5, 6. This is our point P, and then we have our point Q, which has coordinates -2, 2. And then we can consider the horizontal and vertical distances in order to work out the length of the line PQ. And so we have our horizontal distance. We can calculate this by doing 5 from the upper horizontal point and then minusing -2, and this gives us 7 for our horizontal distance. And similarly for the vertical distance, we have the 6 and then we minus the 2, which is the lower vertical point, and so we get 4. And therefore the length of the diameter, which is PQ, and then all squared by Pythagoras, is going to be equal to the square of the horizontal distance plus the square of the vertical distance. And so we get 7 squared and then plus 4 squared. This gives us 49 plus 16, and therefore this is going to be 65. And therefore the length of the diameter, which we've written as equal to PQ, is equal to the square root of 65. Our fifth step is to find the length of the radius. We have that the length of the radius is 1/2 the length of the diameter. And so we're going to get 1/2 of the square root of 65. Our sixth step is to substitute the values of the centre and the radius into the general equation of a circle. The general equation of a circle is x minus a all squared plus y minus b all squared is equal to r squared. And so by taking our centre, which we found via the midpoint of the 2 points on the diameter, which is at 3 over 2 and 4, and also the value of the radius, which we found as equal to 1/2 lots of the square root of 65, we can conclude that the value of a is 3 over 2, the value of b is 4, and the value of r is 1/2 root 65. And therefore we can substitute in and we get the following. We get x minus 3 over 2 and then all squared, and then we have plus y minus the value of b, which is y minus 4, and then we have all squared, and then we get r squared, which is the 1/2 root 65, and then all of this also squared. And so by expanding out the right hand side, we get x minus 3 over 2 all squared plus y minus 4 all squared, and then this is going to be equal to, by squaring, we get the 1/2 squared times the root 65 all squared, which gives us 65 divided by 4. And so our last step is to write down the equation of the circle. This is what we just found. Our x minus 3 over 2 all squared plus y minus 4 all squared is equal to 65 over 4.
Hey guys, I hope you enjoyed the video. If you are looking for an amazing A-level maths resource, join me today in my series of engaging bite-sized video tutorials. Just click the SnapRevise smiley face and together, let's make A-level maths a walk in the park.